Welcome back. We're continuing to graph rational functions. In this video, we are going to be looking at the example y is equal to x to the fourth minus 5x cubed minus x squared plus 5x over x cubed minus 2x squared minus 8x. This particular problem has a lot of things going on in it, but we are just going to approach it the same way that we approach all of our problems. So the first thing we want to do is fully factor the problem because we want to find our domain restrictions. So fully factoring in this particular problem is a little bit more complicated because I have a fourth degree polynomial in the numerator. One thing that is going to decrease the complexity is I notice that I have a common factor of x in the numerator that I can factor out, giving me x cubed minus 5x squared minus x plus 5. And I can pull out a common factor of x in the denominator, leaving me with x squared minus 2x minus 8. The numerator is factorable through grouping. So I want to go through and do some grouping. When you group, if you group our first two terms and add the second two terms, you can factor out a common factor, and this will become x times x squared minus 1 times x minus 5, and the denominator will become x times x minus 4 times x plus 2. The numerator further factors to be x plus 1 times x minus 1 times x minus 5 over x times x minus 4 times x plus 2. So factoring that numerator is probably the most difficult part of this problem, and you're going to use grouping. So if you don't remember how to group, really take a look at this problem and take your time to step through it to get to this factored numerator, because that's really important, and grouping is a common factoring thing. So now that I have my graph completely factored, I'm looking for my domain restrictions, which are when there is a number divided by 0. So any value that makes my denominator equal to 0 is going to be a domain restriction. So that is x cannot be equal to 0, 4, or negative 2. Now that I have fully factored and found my domain restrictions, I'm going to simplify. The only thing that can be simplified here is that I can cancel out that x. So canceling out an x means that this is my simplified equation. I am going to have a hole. This is going to be a hole where x is equal to 0. So there's now a hole in my graph when x is equal to 0. And to find the ordered pair of that, I am going to plug 0 into my simplified equation. So when I plug 0 into this simplified equation, I am going to get 1 times negative 1 times negative 5 over negative 4 times 2, which is positive 5 over negative 8. So I have a hole at the point 0, negative 5 eighths. The other two domain restrictions that did not cancel out and become a hole are going to be vertical asymptotes. So this graph will have an asymptote at x equals 4 and x equals negative 2. So I'm going to go ahead and graph those on my graphing space. So now I am done with my vertical asymptotes and holes. So I've really done